So this is a summary of everything we just learned real quickly. We got our zero, first, and second order. Like I mentioned before, all the rate laws, in this case differential rate laws, are going to be very similar. We're going to have our rate equals to K times our concentration. And depending if you have zero order, first order, second order, that's going to impact everything else, right? I'm going to give you the units for our K here. So our units for our K is going to be dependent right on the order. So if you got a zero order, your units are going to be big M molarity times S minus 1. So basically, if you see S minus 1, that's just M over S. Okay, that's basically what it is. First order is a little bit different. We just got our seconds minus 1. And we understand, right, first order is because it's independent of that concentration. Second order, we got our molarity on the bottom, seconds on the bottom, 2 here. And then, of course, we have our integrated rate laws. So like I mentioned before, the integrated rate laws for each of these orders are pretty different from each other, okay? Similar, but pretty different. If we look at zero order, we're going to have our concentration equals negative KT plus our initial concentration. First order, we got our ln, natural log of concentration, equals to our negative K times T plus natural log of the initial concentration. All right, so these are pretty similar, but we got this natural log here. And then we have second order, which in this case, we got 1 over concentration equals to KT plus 1 over our initial concentration here. So each order has a different integrated rate law. And because of this, when it comes to plotting, right, that data, our plots are going to always look different in this case. All right, so when I say different, right, you can have similar slopes like we see here, but look at what's on your y-axis. That's going to be the key difference, right? So for zero order, you're going to have your concentration on your y, your time still on the x, but then, right, our slope is going to be negative k, and our y-intercept is going to be this concentration of A, all right? And then we could just see the half-life expression as well, too. And then if we look at first order, right, once again, y equals mx plus b, we got our ln of A, right, on our y. We have our x-axis still being t, negative k, our slope is going down, right? And then our y is our ln of our concentration. And then we got the same thing going down here, right? We're going to have our 1 over concentration, as we see over here. And then x, in this case, we're going to have a positive slope. So this is what we see over here, and 1 over our concentration of our initial, which we see over here. Okay. So yeah, this is basically everything summed up. This is integrated rate laws of your zero, first, and second order.